Today we are going to discuss Pearson Edexcel AS Chemistry Paper 3, January 2020. So let's start the paper. Question number 1. Tests were carried out on some pairs of compound. Bromine water was added to separate solutions of calcium chloride and sodium iodide. State one different observation for each reaction. When you will add bromine water into this solution of sodium chloride, because bromine is less reactive than chlorine, so it cannot displace chlorine from its compound. So there will be no change. But when you will add bromine into sodium iodide, because bromine is more reactive than iodine, so it will displace iodine from its compound and it will form sodium bromide. So what observation you will see with the chlorine, because there will be no change, but due to the presence of the when you will add bromine water in the solution, already in a solution of sodium chloride, so it becomes dilute. So the bromine water turns lighter in color due to dilution, otherwise there will be no change. So you can write that bromine water turns lighter due to dilution, otherwise there will be no change. Now with sodium iodide, what will happen? That the bromine will replace iodine from its compound, and as a result the iodine will be left behind and the solution will turn darker brown and black or gray solid. The second part, name a test with the expected observation to confirm the presence of sodium ion in these compounds. Now sodium ion, it's positive ion, so you know that we use the flame test to test for the presence of positive ions of metals. So flame test, and in the presence of sodium ion, the flame color will be yellow. Now barium chloride solution and hydrochloric acid were added to separate aqueous solution of ammonium sulfate and ammonium nitrate. So you know that barium chloride and hydrochloric acid, these reagents are used to test for the presence of sulfate ions. Yes. So this is sulfate ion test. So if you will add barium chloride and hydrochloric acid in ammonium sulfate and ammonium nitrate, so what will happen? That in ammonium sulfate solution, barium sulfate will form. As a result, white precipitates will be observed. And in ammonium nitrate, because there is no sulfate ion present, so there will be no precipitate, no change. Now give a test with the expected result to confirm the presence of ammonium ion with the ammonium compound. You know how we can test the ammonium ions? By adding aqueous sodium hydroxide and heat. So add aqueous sodium hydroxide, heat solution. So as a result, the gas evolved, and the gas turns damp red litmus paper blue. Now, acidified potassium dichromate solution was added to two test tubes, each containing a different alcohol. The test tubes were placed in a warm water bath. The alcohols were propane 1-ol and 2-methyl propane 2-ol. State what would be seen for each alcohol, which would allow you to distinguish between them. Okay, so you are adding potassium dichromate, and you know the two alcohols which are given here. The first is propane 1-ol. Propane 1-ol is a primary alcohol, and 2-methyl propane 2-ol. 2-methyl propane 2-ol is basically this one. 2-methyl propane to ol. So you can see this is a tertiary alcohol. So what will happen then you will add potassium dichromate. It will turn green in the presence of primary alcohol, and there will be no change with 2-methyl propane 2. Now give a chemical test with the expected observation to confirm the presence for the hydroxy group. So what is the test? Add phosphorus pentachloride PCl5, and you can see the steamy fumes. So you can use this test. Now part D, acidified potassium manganate 7 solution was added to separate test tubes containing samples of hexane and hexene. Hexane is a saturated hydrocarbon and hexene is unsaturated hydrocarbon. The test tubes were shaken gently. State which would be seen for each compound which would allow you to distinguish between them. So when you will add potassium permanganate, it's basically purple in color. So in the presence of saturated hydrocarbon hexane, it will remain purple. So it remains purple, no change in color. In the presence of double bond hexene, it will turn colorless. So this is also a test which can be used to distinguish between unsaturated hydrocarbons and saturated hydrocarbon. You are familiar with the very famous test, the bromine water test. It is a very famous test, but this test, potassium permanganate, can also be used to distinguish between these two. Now move on to question number 2. A class of students carried out an experiment to determine the enthalpy change of a reaction of magnesium metal with hydrochloric acid. The following method was used. A 1 meter length of magnesium ribbon was cleaned using sandpaper. You know, sandpaper is used to remove any layer of oxide which is formed over magnesium. Now they have used 50 centimeter cube of dilute hydrochloric acid and excess placed into polystyrene cup and the temperature measured. A 10 centimeter cube of length of magnesium ribbon was added to the hydrochloric acid. Now the measurements and the values given here. Question number 1. Calculate the number of moles of magnesium in 10 centimeter length of ribbon used in the experiment. So you need to calculate the number of moles. For that we need mass over mR. We have the mR of magnesium. We have the mass given here 0.86, but this is the mass of 1 meter and we need the mass for 10 centimeter. So for 10 centimeter we need to calculate the mass. You know, 1 meter is equal to 100 centimeter. And we have the mass of 1 meter, that is 0.86 grams. So 10 centimeter will be equal to 0.1 meter. So the mass will be 0.1 into 0.86. So the mass will be 0.086 grams. So this will be the mass, and you can calculate the number of moles by using mass over mR, and the number of moles will be 3.53 10 to the power minus 3 moles. Now you have the number of moles here. Move on to the next part. Calculate the enthalpy change for this reaction including a sign in units. Give your answer to an appropriate number of significant figure. Specific heat capacity of the solution is given here 4.2. Density of the mixture is 1 gram per centimeter cube. Now you need to calculate the enthalpy change for the reaction. For that, first you need to calculate the temperature change. You know, the final temperature of the reaction is 29.2, initial temperature is 21.4, that's given in the table above. So the temperature change will be 7.8 degrees centigrade. Now you need to calculate the energy change. That is Q. The formula is Q is equal to M into C into delta T. Delta T is change in temperature, C is the specific heat capacity, and M is the mass. So we have all these values. Now the mass of the solution will be taken. You know, here 50 centimeter cube of hydrochloric acid is used here. So 1 centimeter cube is equal to 1 gram. So here the volume will be considered as mass here, and we will use 50. Now C, the value of C is 4.12 and the delta G change in temperature is 7.8. So the value will be 1638 joules. And if you will convert this into kilojoules, you need to divide this with 1000. So it will be 1.638 kilojoules. And because you need to calculate the energy per mole, so energy per mole you have 1.638. So you will divide this with the number of moles which you have calculated. That is 3.5391 10 to the power minus 3. So the energy per mole is 462,830 joules per mole. And if you will convert this into kilojoules, that will be 463 kilojoules per mole. So, and because this is exothermic reaction, so the value will be negative. Now move on to part B of this question. The maximum uncertainty each time the thermometer was read was plus minus zero point 0.1 degree centigrade. You know, when we use thermometer, we usually take the initial and final reading. So we multiply percentage uncertainty with 2. So how we will calculate the percentage uncertainty? The percentage uncertainty is 0.1 because we are taking thermometer value, so we will divide this with 2, and the value on thermometer, the change in temperature is 7.8. So because we are changing the percentage uncertainty, so we will multiply this with 100. So the answer is 2.56%. This is the percentage uncertainty. Now suggest one way of reducing the percentage uncertainty in measuring the temperature change without changing the apparatus or just repeating the experiment. Okay, you know that if you increase the values, the percentage uncertainty decreases. So if we take the greater mass of magnesium, so the value of uncertainty the percentage uncertainty will decrease. Or the other way is also to use the smaller volume of HCl, because HCl is in excess. And why we are doing this? Because so that the temperature change will be greater, because if we are using the greater mass of magnesium, there will be more reactions, so there the change in temperature will be high, greater. As a result, the percentage uncertainty will decrease. Now C part, one student carried out the same experiment but used a glass beaker instead of polystyrene cup. State how this would affect the value of the enthalpy change obtained. Justify your answer. Okay, so what will happen? Because the heat loss will be high, because polystyrene is an insulator. So the enthalpy change value will be less negative than it should be. Why? Because the heat loss will be greater if we will use the glass instead of polystyrene. So there will be more heat loss into the surrounding. As a result, the enthalpy change value will be calculated less negative. So that will be the error in the experiment. Now explain why the magnesium pipette was cleaned with sandpaper before weighing. I have already discussed the reason, and I was reading the question. To remove the magnesium oxide, layer basically. Because the enthalpy change will be different if there will be magnesium oxide instead of magnesium. So we clean the magnesium.